Hello guys, welcome back to the channel. In this particular video, I will explain the problem Solve the Sudoku. This problem is really important and frequently asked by companies like Amazon, Microsoft, Flipkart and many more. So guys, make sure you stay tuned till the end of the video. Starting with the problem statement, so it says that you are given an incomplete Sudoku configuration in terms of 9 cross 9 2D square matrix. The task is to find a solved Sudoku. For simplicity, you may assume that there will be only one unique solution. Okay, so guys, I guess most of you already know what exactly is a Sudoku, right? But for those who don't know, let me explain. Sudoku is basically a puzzle-based game where we are given an incomplete 2D 9 cross 9 matrix, and our task is to complete this particular matrix. And guys, each value in this matrix ranges from 1 to 9, and for those boxes which are empty, we have to write a value from 1 to 9, right? And these empty boxes are basically represented by a 0 in the matrix. And guys, there are some rules, like we can't replace the element in the cell which is not blank. So let's say I'm talking about this particular cell. You can see that there is already one value present in this cell, which is 1, right? So I can't replace this cell. I can only touch those cells which are empty. And while filling values in this particular cell, we have to make sure that these three conditions are satisfied. Now guys, this is very important, and these conditions are something which makes Sudoku a tricky game, right? So let me explain each of these conditions. The first condition says that each of the digit 1 to 9 must occur exactly once in each row. So let's say I want to fill value in this particular empty box, right? Okay, first of all, let me explain, let me remove this stuff so that I can get some empty space. Now guys, uh, let's assume that I want to fill value in this particular cell, right? So what are the options I have? I can write any value from 1 to 9, right? But what are the conditions? See, first of all, let me write every value from 1 to 9. I can write 1, 2, 3, 4, 5, 6, 7, 8, 9. Any of these value can be written in this particular box, right? But the first condition says that each value from 1 to 9 must be occurring only once in each row, right? So let's say I want to fill value in this particular row, so I'm pointing to this row, right? And guys, I have to make sure that each value is present once, so I can't write 4 in this particular row. Why I can't write? Because if I write 4 in this row, then you can see that 4 is occurring more than once. This is not something that we want. So guys, we can't write 4. Similarly, so I can eliminate 4 from this particular space. After this, I can't write 5, 6 as well, and 8 as well, and 3 as well, right? Because all these are going to increase the frequency of that particular element. So 3 I can't write, 8 I can't write, 6 I can't write, and 5 also I can't write, right? Okay. Now the second condition here says that each of the digit 1 to 9 must occur exactly once in each column. So now the same rule, but with the current column. So you can see that if I want to fill value here, so this is the column that I'm pointing to, and I have to make sure that every value in this column is present only once. So I can't write 8. 8 is already eliminated. I can't write 5 and 3, already eliminated. I can't write 2 as well. So guys, I have to eliminate 2 from here as well, right? Because I can't write 2 in this particular space. Now the third condition says that each of the digit from 1 to 9 must occur exactly once in each of the 9 3 cross 3 sub boxes. So guys, pay attention here. You can notice one thing in this particular grid, that there are 9 3 cross 3 boxes. One is this one, second is this one, third is this one, right? Similarly, 3 are present here as well, and 3 are present here. So there are 9 3 cross 3 boxes, and we have to make sure that each of these boxes contains the number from 1 to 9 exactly once, right? So this means that I can't write 3, I can't write 5 as well here, I can't write 2, I can't write 7 as well. So I have to eliminate 7 as well. Guys, you can see that we have eliminated many options, and now we are left with two options, 9 and 1. So this is the method which we can use to fill values in this particular grid, right? So that we can solve the Sudoku. This is how we solve the Sudoku manually. But this time our task is to write a program which which is going to solve the Sudoku, right? So guys, how we can write this program, I'm definitely going to explain this particular part in the solution. So now, without any further delay, let's talk about the solution. Okay, so I have written the same example here, and I have written the set of rules as well. Guys, I'm going to use this particular grid in order to explain the approach. See, the approach is quite simple. We are simply going to traverse the whole matrix, and while traversing, when we get an empty cell, then we have to solve for that particular cell, right? How we can solve? We can basically try out every value from 1 to 9. So this is the approach we are going to follow. Let me explain with the pseudocode so that the idea gets more clear to you. So what we have is, we have a function of boolean type according to the problem, right? Let's say the function name is solve, and this is going to take a grid as the parameter, and this grid is basically the input grid that we have, right? First of all, let me talk about the return type of the function. If this function returns true, if this function returns true, in that case grid is solved, right? And if this function returns false, in that case grid is not solved. This means that no solution exists, right? So this is what the return type of the function is. After this, the first step is to traverse the whole matrix, right? After this, we are going to check for an empty cell. So how we traverse a matrix? A matrix is a 2D array, so we need two pointers for I equals to 0, I smaller than, okay, let me write 9 here, because we have total 9 cells, right? And this is going to remain constant throughout the input set. So we have 9 cross 9 grid, and this is how we can traverse the grid. I need one pointer for like row, and the second pointer for the columns. So this is j plus plus. Inside this, I will get every particular cell. So for every cell, I have to check one condition. If okay, let me change the color, guys. So I'll choose black color, and I'll simply check if my grid of ij is equal to 0, right? This means that, okay, uh, this means that we have got an empty cell. You can see that even in the problem statement it says that 0 are basically going to represent every empty cell, right? So guys, see, this is how we can check. And now the data of this particular block I'm going to write here, because the space is not enough, right? So guys, see, uh, once we have got an empty cell, then we can try out writing every value from 1 to 9. But hold on, while writing the value, you have to first check these three conditions. Only if these conditions are true, then only you are going to try out that particular value by writing it here, right? So guys, you have to make sure that you check these condition. How we are going to check these condition? For now, let's say we have an is valid function, and this function is going to check, right? This function is going to do the task for us somehow. I'll definitely talk about this function as well. So guys, see, I can start a loop from 1 to 9 for k equals to 0, then okay, my bad, for k equals to 1, then k is smaller than equal to 9, then k plus plus. This is how I can try out every value from 1 to 9, and I will check if is valid. If is valid, this means that I can write that particular value in the cell, right? If is valid for number, grid, current row and current column, these are the parameters that I need to pass. If the condition is true, in that case I can simply say that, okay, now I can write that particular value in the cell, right? So I'll say that grid of ij is equal to k, right? K is basically representing the value that I need to replace. After this, I need to check whether this is going to give me the answer or not, right? So I have to call the same function, because I have some filled cell and I have some empty cell. So this is again a same sub problem, right? So I will say that, okay, call the same function. How we can call? I can simply write solve here, and this is again going to take the remaining grid. After this, I have to store the answer somewhere, because this is going to return a boolean, right? So I will store it in answer variable. Inside this, guys, if my answer is equal to true, right? In that case, I can simply return true. I can simply return a true, because you can see that if this is going to work for the value 1, then I can say that, okay, I have got my answer, so I can simply return 1, and this call is basically going to fill every value recursively, right? After this, let's say my answer is not true. This means that I'm not able to solve the problem, right? So in that case, I need to again write an empty cell here. So I'll say that a grid of ij is basically equal to 0, right? This is basically undo that particular operation which is not going to work. Quite simple, right? Let's say I write 1 here and I'm not able to solve the problem for 1, so I'll simply write 0 again. This means that this is an empty cell again, right? And now I can try out other values, right? Like 2, 3, 4 till 9, right? Guys, this is the approach that we are going to follow. Now let's say I have tried every value from 1 to 9, and nowhere I was able to get my answer as true, right? So this means that I'm not able to solve the problem for any value from 1 to 9. So if this loop is completed, I can simply write return false. Now guys, I hope the idea is clear to you. So this is the code that I'm going to write inside this particular block, right? After this guys, if my whole loop is completed, let's say I'm traversing the grid and nowhere I was able to find an empty grid. I was not able to find an empty cell because this condition is looking for an empty cell, right? And if there is no any empty cell, then I can simply say that okay, now my grid is solved. So if this loop is completed, I can simply write return true. Guys, this is the approach that we are going to follow. Now I hope the idea is clear to you, right? The only thing that we are left with is valid function, isn't it? Okay, so now guys, I'm simply going to remove this particular code so that I can get some space in order to explain you the dry run, right? So guys, I hope you have noted this particular code. Let me remove this so that I can get some space here. Okay, this problem is really interesting guys and based on backtracking. So I want you to practice some more questions based on backtracking so that you will get more idea about how this algorithm works, right? So now what I'll do is I'll simply explain you the dry run. And guys, if I use this particular example for dry run, then it is going to make the explanation more complicated, right? And we don't have enough space, so we are going to pick up a smaller matrix for this. So let's say we have this particular submatrix which is a 3 cross 3. Let me write it here. So what I have is I have 3, then empty space, then 6, after this 5, 2, then empty space, then I have empty space, 8 and 7, right? This is the first 3 cross 3 matrix which we have. So guys, we have to solve it. Let's say we have to solve it. So for the first empty cell we can try out every possible value, right? So from 1 to 9. So how many ways are there? There are 9 ways that we can try out. Of course we are going to check these conditions as well, so some ways will get eliminated like 4, 3 and 6 and 2 and 8, right? But we are talking about the worst case. Let's say we have the worst case, so we can try out any like every value from 1 to 9. I'll try 1 here, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9. After this is about the one cell. Let's say I try writing 1 here, which is this particular case, right? After this, again there are 9 possibility for this particular case, so again there are 9 possibility for each case, right? Right, this is how we are going to solve the problem. So how many ways are there? There are multiple ways. 1 for this, then 9 for this, then 9 raised to the power 2 for this, and like this. So it totally depends upon how many empty cells we have, right? This is going to decide the time complexity, but this is also going to explain the approach, right? Now I hope the idea behind the approach is clear to you guys. We are basically trying out every possible value recursively, so you can say that this is brute force approach, right? Because brute force again do the same thing. Now let me talk about the function which is invalid, is valid function, my bad. Okay. Okay, so these are the three conditions that I need to check. Now guys, I'm going to take an example. Let's say this is a cell where I want to fill a value and the value is equal to 2, right? So I want to check whether it's valid to fill this particular value here, right? Of course, it's not valid because of this 2, but I want to write a function, right? This is a scenario. So this particular function is going to take 4 parameters. The first one is value k. K is basically representing the current value that I need to check, right? After this, I have a grid as the second parameter. Then I have the current row. I need current row for this particular row, right? So that I can check the first condition. After this, I need current column as well so that I can check the second condition. Now, these are the 4 parameters that I need, right? Now, guys, starting with the first condition, so what I can do is I can try out every possible column of the current row, and if any value of the column is equal to k, then I can say that okay, it's not valid because I don't want the same value repeated, right? So I can simply start a loop for I equals to 0 to I smaller than 9, then I plus plus. Inside this loop, I'm going to check if my grid of current row is going to remain constant because we have only one row, but column is going to change. So I'll say that okay, current row and the changing column is equal to k, then I can simply return false because in that case it is not valid to fill this particular value here, right? Similarly, I can check the second condition for column as well, like right, the like code is very similar. I can start a loop again, I equals to 0, then I smaller than 9, then I plus plus. Inside this loop, my column is going to remain constant, right? So I'll check that, okay, if my grid of I, changing row, and the constant column is equal to k, then I can again return false. you can see that this is going to check for this particular column, and even this is the point where I will return false because 2 is already present here, right? Okay, now the what is the third condition? The third condition is this one. It says that each of the digit 1 to 9 must occur exactly once in 3 cross 3 submatrix, right? For each 3 cross 3 submatrix. Now see guys, this is very tricky to understand. Let's say I'm here, so I need to check for this particular 3 cross 3 matrix, right? And let's say I'm here, so I have to check for this one. Let's say I'm here, so I have to check for this one. Let's say I'm here, so I have to check for this one, right? This is how we are going to check. Now let's say guys, this particular cell is represented by current row, current column, right? Of course we can calculate the definite value, so it is nothing but 0 1 2 3 4 and 1 4, right? This is 1 comma 4 where current row is equal to 1 and current column is equal to 4. So I need to check, I need to get this particular index so that I can get a starting row and starting column in order to start traversing this particular 3 cross 3 matrix, right? I need to get starting row and starting column. So in order to get starting row and starting column, I need to explain you something. So guys, first of all, I'm going to remove all the stuff, right? I'm going to remove everything from here. So, uh, okay, let me remove this. Guys, first of all, I'm going to write the index of these starting points, right? The value which can be starting point. So this is 0 comma 0, this is 0 comma 3. After this I have 0 comma 6, right? What is this? This is 3 comma 6. This is okay, this is nothing but 3 comma 3. Then this is 0 comma 3. After this, if I come here, then this is 6 comma okay, my bad, this is actually 3 comma 0, right? And this is 6 comma 0, then this is 6 comma 3. After this is 6 comma 6, right? Now guys, I want you to notice one thing here, that every starting index is an exact multiple of 3, right? Whether you talk about the row or you talk about the column. So this means that if I'm able to convert current row and current column in the terms of multiple of 3, then I can definitely say that that particular index is going to be start row and start column, right? So guys, how we can do this? Let me explain. uh, I can represent any current row as a multiple of 3, any multiple of 3 plus current row mod 3, right? This is how I can represent. For an example, let's say I have 7, so I can represent 7 as 6 plus 1, right? And 1 is the remainder when we divide 7 by 3, so I can write 6 plus 7 mod 3, isn't it guys? You can see that 6 is basically multiple of 3. Even we can do this with any number. So let's say I have 11. 11 can be represented as 9 plus 2. 9 is multiple of 3 and 2 is basically remainder when 11 is divided by 3. So that's why I have written this, right? And can I say that if this is current row, so can I say that this multiple of 3 is nothing but starting row? Because if there is any multiple of 3, then this is definitely going to be starting row, 0 3 and 6, right? So I can write this. Similarly, I can write current column as starting column plus current column divided by, okay, current column mod 3, right? This is how I can write. So this way I can get my starting row and starting index. My starting row is basically equal to current row minus current row mod 3, and my starting column is equal to starting column minus current column mod 3. Guys, this is very important formula. Let me remove this, and after this I'm going to write this particular formula, right? And now we can write our condition. See guys, we have got our starting index and like starting row and starting column, right? So let me write it. First of all, I'm going to change the color. So I'll write starting row equal to current row minus current row mod 3. Similarly, starting column equal to current column minus current column mod 3, right? Now guys, I have got my starting row and starting column, so I can traverse the whole matrix that we have, right? Let's say this is my starting row and starting column, so I can traverse this particular box. How I can traverse? I can start a loop for I equals to 0 and I smaller than 3. Why I'm checking 3? Because this is 3 cross 3, right? I plus plus. And similarly inside this I can check for j equals to 0, then j is smaller than 3, then j plus plus. This is the standard loop from I equals to 0 to I equals to 3. This is going to check any 3 cross 3 matrix, right? But I need to start from this point, so I'll say that okay, uh, if my grid of starting row plus I, this is going to give me the exact index. Similarly, starting column plus j, this is going to again give me the say like current index, right? if it is equal to k, then I can simply return false. Guys, this is the technique that we are going to use in order to check the third condition. Once you have checked these three conditions, then your task is done, right? Guys, this is all about this given problem, like how we can solve the Sudoku. Now the only thing that we are left with is the time complexity, right? I have already mentioned the time complexity. If you guys remember that particular dry run, we have one let's say I have this example, 1 empty space 3, then I have 4, then 5, then empty space, then I have 7, 8, 9, right? So for this you can see that we have got two empty spaces here, right? I have to fill them both. So in worst case we can call the function 9 times, right? Because we have 9 options from 1 to 9. So this is the worst case. After this, again for all those 9 cases, we can again call the function 9 times. So 0, 9 raised to the power 1, 9 raised to the power 2. Why 9 raised to the power 2? Because we have two empty cells, right? Let's say we have three empty cells, then we will have 9 raised to the power 3. In worst case, in 9 cross 9 matrix, we can have like 9 cross 9 empty cells, right? Or I can say that like writing in a standard form. So I can say that n cross n empty cell we can have, right? So the total time complexity in that case is going to be 9 raised to the power n cross n, right? This is the time complexity that we have. Talking about the space complexity, so see guys, we are not using any extra space, so space complexity is going to be O of 1. This is excluding the recursion space, right? If we include the recursion space, then it is going to be O of n cross n, because you can see that we are calling the function not more than O of n cross n times, right? This is the worst case. So now I hope everything is clear to you. Let me show you the code quickly. So guys, this is the code. See, this is the starting point of the code where we have a function solve Sudoku. Then we are simply like traversing the whole matrix, and while traversing we are checking for an empty cell, right? Once we have got an empty cell, then we can try out every value from 1 to 9, and this is how we can check the condition, right guys? First we are overwriting the value, then we are checking this particular like, okay, we are calling the function, then we are checking the condition, and if the condition is not true, then we are performing backtracking, right? I hope the idea is clear to you guys. And this is my check function. You can see that this is for row, this is for columns, and then we have for 3 cross 3 matrix or sub matrix, right? The same code is written in Python as well. You can see that this is the Python code, guys, and this is the Java code that we have. This is the starting point of the Java code, and after this I have this particular code, right? Now guys, this is all about this video. Thank you.